Okay, so let's get on with the presentation, sustainability and UV protection. Is it a myth or is it a reality? So, welcome to the meeting room, and the contents of the presentation will be an introduction to UVR and VL protection, that's visible light. We'll have looking at sustainability, the direction and guidance we get from sustainability. And then we'll look at sustainability and UV protection, and we will finish with an observation, a discussion, and a conclusion. So that sunscreen manufacturers wanted to develop effective, safe, and stable products with the right sensory to satisfy their customers and regulatory requirements in their target markets. So when developing a sunscreen, it's important to establish the protection criteria. So here's a cross-section of our skin. Here is the wavelengths that we'll be concerned with. And these will be measured from the short wavelength through to the longer wavelength. And we start off with our ultraviolet. Here is our UVB, 290 to 320. UVA2, 320 to 340. UVA1, 340 to 400 nanometers. And as you can see, most of the UVB is taken up in the upper layers of the skin. The UVA2 penetrates a little bit deeper, but the UVA1 gets quite deep within the skin down in the hypodermis, and this is where it disrupts the collagen and it starts to destroy the elastin bonds, which is the beginning of premature aging. We then have visible light between 400 and 760 nanometers, and the prominent one there is blue, which penetrates down into the hypodermis, but we also see red, and red goes further than the blue, but we mainly concentrate on blue from a marketing position. And the final spectrum is the infrared, and it's also divided into three components: IRA, B, and C. And IRA will penetrate even further than the visible light red. But as we get further along the spectrum, we see that IRB becomes less, and so does then the IRC. And the IRC out to 3,000 nanometers has very little penetration into the skin. So this end of the spectrum, very short wave. Here we have long waves. This is very energetic energy, and this is less energetic energy. So what do I mean by energetic? Because here we see the burning spectrum. And when we look at the UVB, 85% of the erythema is responsible by UVB. 9% UVA2 and 6% UVA1. Now, 15% of erythema is generated from UVA, but when we look at total UVA, that's UVA1 and 2, but when we look at UVB and UVA2, this is 94% of the erythema. So most of the erythema and burning is happening in this spectrum here, hence known as the burning spectrum. Tanning is also from UVB out to UVA. The immediate tanning is from the UVA, and the tanning from UVB takes up to 5 to 7 days after the maximizing of the burn. So UVB is delayed pigment darkening, whereas the UVA is almost immediate, with immediate pigment darkening and then permanent or persistent pigment darkening. When we look at skin cancer, we can see it's attributed to UVB and out to the visible light, probably into the into the blue spectrum.